Okay, so here we have PV equals nRT, and we want to solve for T and V for this system. The system being the water that is initially at 1 atm, and no, the container is initially at 1 atm with air inside of it and 1 kilogram of liquid. And we want to know the total volume of, no, and then it is sealed without removing the air, and then heated to a pressure of 2 bars. And we want to know the total volume of that container and the final temperature. And that is, and what we're given is that is the 2 bar, and that the number of moles of air, or no, water vapor is 0.3. So then we want to solve for V total and TF. Now to start, losing this marker, V tot, like the total specific volume, I believe it is. Total specific volume is equal to the specific volume of air and specific volume of the liquid water and the vaporized water, and then the pressure total is equal to the pressure of air plus the pressure of the water vapor. And then from there we can plug in, or we want to solve, and then from there we want to find the pressure of air, and that is the number of moles of air over, or times RT over the volume of vapor that's really bad, hard to see, but from there we know that the number of moles of liquid, or no, from there we know that the volume of liquid is equal to the total amount of water, or the total mass of water, minus the mass of water vapor over the density of liquid water. And then from there, because we know that top part because the mass of water, or the total mass of water, is equal to the mass of the vapor plus the mass of the liquid. And then we know the final pressure, and then for the total volume, we have it's equal to, so far, is equal to the mass of liquid water over the density of water plus, and that's what we're gonna try to find is the, or no, we know we know that the volume of vapor is directly related to the Antoine equation through the pressure. And then we also know that the pressure of water vapor is equal to 10 to the A minus B over the final temperature plus C. And that's directly from the Antoine equation. So from there, we just need to find the number of moles of air. And we're going to do that because we know we're going to do that with PV and RT. So we know the number of moles of air is equal to the pressure of water, or no, pressure of air over RT times the vapor pressure. And we're getting that directly from this equation that I had right here. And then with all of these equations together, we can start to code. Okay, so here's a correction for the last one I've written down. We have knowns for this, and I forgot to write those down. So we have the initial pressure of air is equal to 101,325 pascals. The initial temperature is equal to 298 Kelvin. The final pressure is equal to 20,000 or 200,000 pascals. And then the total mass of water is equal to 1 kilogram. The total volume of water in that sense is also 1 liter. But that's a different V total. And then we have V water vapor is equal to 0.3 moles. And then we can multiply that by what is it? 1 over 18 to the third. Yes. The number of water moles is mass of water over 18 times 10 to the third, or negative third kilograms per mole. And that's just so we get the number of moles of water. It converts kilograms to mole, or moles to kilograms. That's how we can convert from moles to kilograms. Sorry. And then those are our knowns. And then also we have one other equation that I did not remember to put down. Where is it? No, I think that's actually it. So I remembered the other equation that I was going to do earlier. It was in regards to this air one. And so what we have here is we have the number of moles of air is equal to the pressure of air times the volume of water vapor. The volume of the vapor of water over RT. And we can expand that to the pressure of air being the pressure total minus pressure of water times the initial temperature times the total amount of water, total volume of water, I should say, minus, I'm running out of room here, so we're going to rewrite this stuff, minus the mass of water, liquid water specifically, over the density of liquid water. That's why I had this equation here too, was VVAP, or water vapor pressure, in the total one. I forgot to expand that one, finish that one rather. So yeah, this is me just playing catch up. Okay, I have found one final equation that I have forgotten, and it is the number of moles of water is equal to the water vapor pressure times the volume of vapor over R times the final temperature. Okay, so I just had to completely scrap a bunch of recording because apparently this hotkey that I was using decided it wanted to put my camera and cover the screen. Okay, so where I left off was I had, let's see, Control V. I had a bunch of this stuff, which is like this Git stuff, which is all just to get a bunch of code that has already been written and run that. See, there we go, and it's cloning. And so now we have that to use, and then what we can do is import tools.che as ch. No. And then we want to, what are you doing about that? Okay, well, we'll see. And then from scipy dot optimize, we're going to import the root function. It ran right. And then from there we are going to set a variable to mean chem dot water properties, and I think it was, do I need the brackets? Let's try the brackets first. Water, we're going to get the properties of water. That's, oh, why did I put it as CHE tools? I don't want CHE tools, I want CH. Okay, falling back to CPU. That's, I don't even know what that means. And then we want all of our knowns to be done. I got my knowns right here. R is equal to 8.314 kilojoules per mole. The pressure initial is equal to 101,325 pascals. The temperature initial is equal to 298 Kelvin. The final pressure is equal to 200,000 pascals. The total number of water, or the total mass of water, is equal to 1 kilogram. I'm just going to make these. I guess we can make these float. No, we're going to make these floats because I think it likes floats better. And then we need the that's the volume total. And then NWF, which is number of moles of water final, is equal to 0.3 moles. And then from there, we want to define an equation where it is some vector put my mouse on my laptop like an idiot. Some vector, we want the final temperature and the total volume are equal to this vector. And then we're going to plug in all of these equations. So the first one, I believe, is the final pressure of water. No, actually, it's just pressure of water is equal to, from this vapor pressure thing, we have, this is, what this is doing is this has got all the list of data stored on it. I'm pointing at my screen as if you can see that. ChemiTools has all the data values of water, and so we're doing the vapor pressure of water really quickly at the final temperature. And then we're going to have the number of moles of air is equal to P air, pressure of air, times the vapor pressure of water divided by R times TF, or final temperature. Oh wait, hang on, there's more to this. It's not divided by that just yet. It's also multiplied by, that just dropped. Okay. Get that back up there. Can't even remember how many. Oh, volume of liquid total minus the mass of water, which is M. No, it's just M of the liquid divided by, I think it is, we want P dot rho L, rho liquid, of the temperature, initial temperature, and I guess this one's going to be P dot PVAP, and also the initial temperature. And I need an operator in here. Okay. Those are defined. Don't tell me they're not. And then pressure of air. What the hell is going on with this thing? Pressure of air is equal to the number of moles of air, and then the mass of liquid is equal to believe the total mass minus the, I guess total mass is equal to that. Oh, because the mass of vapor pressure is equal to the moles of vapor pressure times 18 times is equal to this times this. Okay, got that. Perfect. So mass of total minus, why did I say times? It's minus, whatever. Minus the times 18 e to the negative 3. And then we're going to want to put in the number of moles of water is equal to P dot P vapor pressure to the final temperature. That's not where I wanted that. Times the volume of the vapor pressure divided by R times the final temperature. And I'm going to put that in parentheses just in case because I never trust these things. And then I guess at that point we want the volume of the vapor is equal to the volume of liquid, no, volume of total water minus the volume of liquid. And then the volume of liquid is equal to the mass of the liquid divided by P dot density of water, rho, that was the density of water, liquid water specifically, at the final temperature. And then I think we're ready to return the total pressure minus pressure of air plus pressure of water vapor that in parentheses and then the pressure of water vapor, and then we're going to return also the number of moles of water minus, because that'll be the total, the number of moles of water minus the final number of moles of water vapor specifically. Okay, I think that's vapor, but yeah, should be. And then I guess now it's time to run this, then run this. Okay. Is that invalid syntax? Do I need to have you first? I deleted PA or equals in air, didn't I? Pressure of air. No, okay, well I did. See, there's got to be parentheses there. Forgot those as usual. Wait, hang on. These aren't even supposed to be here. What? I thought I deleted these taxes. These don't even need to be here at all. Is there not a parentheses? Okay, it was a parentheses. This is stupid. And now it's time to guess. That's not, it's root of this equation. Why am I struggling to find Q? Root of equations. And then let's make a guess and say it's like gonna be 402 liters. Function is not scriptable. Subscriptable. Okay, let me just reset the runtime here. Let's see if that works. Okay. What error? I'm gonna have to take a little break from this and figure out what the hell's going wrong, because I don't know. Okay, so I think I just forgot one equation, and that is, let me get back into Colab. Potentially the final pressure is equal to the partial pressure of air plus the partial pressure of water, vapor. Okay, I like that a lot better. I am still missing something, so hold on. Let's check. Oh, pressure of air does not equal pressure of, or the number of moles of air. It's the number of moles of air times R times the final temperature. Initial temperature. We'll figure this out in a sec. Divided by the vapor pressure of water. Nope, still not traceable. But that is what it is. And it's not dissing this anymore. Okay, so I've been playing around with it. And I think what my problem is I think this is supposed to be pressure initial. I like that better. Gonna have to play with this some more. Okay, so I lost some recordings from yesterday, but what I figured out was that I had like just the final, just the like number of moles of water here. It's actually the number of, well, it's actually the desired number of moles of water, which is the final. And then I figured out that I didn't have a comma in this right here. And then I made some guesses, and I realized there's a range of values here, and these probably aren't correct even though it says true. But like, see if I could even put something as low as like 350 and 0.1, it still works. Oh, wait, I didn't run any of this. It reset the default runtime, so yeah, see, it still says it's true. So I don't know if this is the 100% the right answer, but I guess I will figure that out later.